Today we're going to discuss about exponential function. This is the formula for exponential function, ab to the power of x plus c, where a is the initial point or it's the y-intercept, b is your base, x is your exponent, and c is the asymptote, and the asymptote is a line that your graph tries to approach but will never touch. In an exponential function, we are going to discuss both exponential growth or exponential decay. So what are these? So once again, this is how your formula for exponential growth looks like. Y equals c, where c is your y-intercept or the initial point. 1 is fixed, plus is because it's growth, r is your rate, and t is your time. In this case, exponential decay is the initial point, which is your y-intercept. 1 is fixed, it's a minus the rate, which is r, and to the power of t. Exponential growth looks like this because it's going up, and in this case, just to emphasize, the asymptote here is your x-axis, which has an equation of y equals 0. This is your y-intercept, or that's your c. In this case, this is exponential decay because the graph is going down. This is your asymptote, which is the line that your graph tries to approach but will never touch. This is the x-axis, and the equation for your asymptote is y equals 0. In this case, this is your initial point, which is the c, and that is your y-intercept. So the best way to do this is to give an example. So let's have an example. Example number 1, y equals 2 parentheses 1 minus 0.15 close parentheses x. Let's analyze this. Based off of this one, your initial point or your y-intercept is 2. 1 is fixed, minus indicates that this is a decay. The rate is 15%. Your time is x. And your asymptote, which is your plus c on this side, is a 0. Therefore, your horizontal asymptote has an equation of y equals 0. Let us do this on the graph. Get me a document, a file, new, do not save, and go to graph. Let us start typing this in, which is 2 parentheses 1 minus 0.15 close parentheses caret x, and press enter. There you go. So this is a decay that has an asymptote on the x-axis, which is y equals 0, and your initial point or your y-intercept is at 2. So what if I do my y prime and I change my asymptote to, now I am just going to put 0.85 here, which is 1 minus 0.15 is 0.85. X is still there, but I'm now changing my asymptote to 3. That means that my asymptote will move to y equals 3. So how will that look like on the graph? If I'm going to, this is your old line, I'm just going to go ahead and put here plus 3 and press enter. You now see that this right here is where your imaginary horizontal asymptote is, and your y-intercept has now moved to positive 5. Now let us go to example number 2, y equals x parentheses 1 plus 0.25 close parentheses x. Your initial point or your y-intercept is 3. 1 is fixed. The plus here indicates that we have an exponential growth. The 0.25 indicates your rate, which is 25%. Your time is still an x, and this is your asymptote. So it is y equals 0. So let's go ahead and graph this. Document, file, new, don't save, go to graph, type in 3 parentheses 1.25, which is the sum of 1 plus 0.25 caret x, press enter. This is an exponential growth with a y-intercept of positive 3 and an asymptote of y equals 0. However, if we go back and have our y prime, which is the same thing, 3, 1.25 x, but then I want to move my horizontal asymptote to y equals 1. This is how it would look like, and this time I will not make you remove this line. I will make you have another line here, which is 3 parentheses 1.25 close caret x, but put plus 1, and therefore this is now your imaginary asymptote, which is at y equals 1, and your initial point this time is at positive 4. For our last and final example, we are going to have y equals 2 to the power of x plus 1. Please understand that this is the base and that's the exponent. Therefore, this base is like this one right here, where you have the 1 plus 25. In this case, since this is 2, that means that this was a 1 plus 1. Because it's a 1 plus 1, if this was 0.25, that's 25%. But if this is 1 plus 1, then it becomes 100%. The initial point right here is not the 2, but the number in front of the 2, which is a 1. This is an exponential growth with a rate of 100%, and the asymptote is at y equals 1. Let us go ahead and graph this. Document, File, New, don't save, go to Graph, type in 2 caret x plus 1. That is your imaginary horizontal asymptote right here. It's not being shown, but the asymptote is there. This is your y-intercept. And so if I go back and I have my y prime, which is 2 to the power of x minus 3, that means that I want to change my horizontal asymptote to a negative 3. And so if I do that, and I don't want to remove this so y'all can compare, just press tab and type in 2 caret x minus 3. You can now see that the horizontal asymptote has moved to negative 3, but still your initial point is still 1 away from your asymptote, which in this case is a negative 2.